now.
Okay, Phil. Yeah. Okay. Ladies and gentlemen, I welcome you to all to today's presentation. Today's webinar on glazing solutions and innovations with laminated glass in buildings, which has people from different corners of the world, from Australia to America, in spite of the different time zones. My name is Malvinder Singh, and I'm Market Development Manager for the Asia Pacific region, and I'm the moderator for today's session. And it's a great privilege for me to introduce you to today's speaker, Phil Davis, who is we call as walking encyclopedia on this planet for laminated glass. And Phil has been very actively involved in the code work in Australia and the different standards of the world. And he has also been a guest speaker in China Academy of Building Research. And Phil retired from DuPont after 42 years of service. And he holds an honors degree in chemical engineering from the University of New South Wales. At the retirement, at the time of his retirement in 2009 from DuPont, after 42 years of service, he held the position of architectural director, Asia Pacific for DuPont Glass Laminating Solutions business. As I mentioned before, he's working with Kuraray as a consultant since 2015, and Phil has represented Australia on the ISO TC 160 Glass and Buildings Committee and served as an industry expert on ISO TC 160 working groups on laminated glass and safety glazing tests. So in 2006, he was appointed as a guest speaker of the China Building Materials Academy in Beijing for his extensive work at the Academy on testing of safety glass products. Yeah. Over to you, Phil. Sorry, I just forgot to mention about the webinar etiquettes. Your audio and visual has been turned off to aid the quality of this presentation. There is a facility for you to raise questions at the bottom of your screen. There are a variety of icons. The one shaped like a speech bubble enables you to post comments, and this session will be recorded. For those who are unable to attend, they can request a copy of the presentation. Because this is a live presentation, we apologize in advance if there are any technical glitches. I hope there won't be any issues because we have been good so far. And now it's over to you, Phil.
Thank you, Malvinder. I'd like to add my welcome to all who have joined this Kuraray webinar today on glazing solutions and innovations with laminated glass for buildings. In my 42 years involvement with architectural laminated glass, I have seen amazing growth in the use of laminated glass in buildings and in the development of new laminated glass interlayers, one of which I'm going to share with you today. So this is the content of what I am going to present. But first of all, a few words to begin with about the Kuraray company. Kuraray is a Japanese international chemical company with leading market shares in vinyl acetate derivatives, isoprene chemicals, fibers and textiles, and other materials. The PVB division of Kuraray is a unit in the vinyl acetate derivatives business and produces Tricifol PVB and Century Glass interlayers. Kuraray's Tricifol business is a leading global specialist in the development, manufacture and supply of PVB and Century Glass interlayers for laminated glass applications in the architectural and automotive industries, providing safety, structural integrity, security, sound insulation, UV protection, and other functional benefits. It is the world market leader in the architectural segment. Its service and customer orientation has contributed to that. It is the exclusive manufacturer of Century Glass. It has research and development centres in each region of the world. Parsifal is a global business with 7 manufacturing sites that you can see on this map, 5 R&D laboratories, and 18 sales offices. In Australia, Parsifal World of Interlayer products are distributed by IMCD. Kuraray is well positioned to serve the needs of the glass and building construction industries worldwide. It has the broadest portfolio of laminated glass interlayers in the industry. Our focus today is on the application of this portfolio of interlayers to glass in buildings, which is a significant component of most modern buildings. When we come to the selection of glass for buildings, there are many factors that we have to address. These include the all-important area of safety, load resistance, energy performance, acoustic criteria, aesthetics, security, storm protection, in some parts of the world, disaster protection. And of course, there's always the question of cost versus benefits. And we need to pay attention and comply with prevailing standards, regulations, and we must make sure that the products that are installed, the glass products that are installed in buildings, are fit for purpose. Let's look at ordinary window glass. It's a wonderful material. It provides a view. It allows light in. It's weather resistant. It's durable. It's relatively maintenance free, just a bit of washing. But ordinary window glass is brittle. It shatters on impact with lethal slivers of glass. And it's an unusual material because its strength is highly variable, and there's no one number for the strength of glass as a material. In fact, its design strength is based on a statistical breakage rate. Here we see the probability density for tests on new annealed glass. Minute surface flaws on the surface of the glass result in this large strength variability. They're called Griffith flaws. In the presentation that was recently given by Vaughan Schoss, he pointed out the requirement in the ASTM E1300 standard used in the USA. Now let's see a video of the breakage of float glass. I recorded this in China during our program to develop an ISO safety glass test method. You can see these dangerous glass shards, which are lethal. Because of this, we have safety glazing materials, and these are broadly laminated safety glass and toughened safety glass. Laminated safety glass is a glazing material made by bonding 2 or more pieces of glass together using heat and pressure with 1 or more interlayers of plastic material. When broken, laminated glass resists penetration, so it provides safety by penetration resistance and its post-breakage integrity. Let's see an impact with laminated safety glass. This time at 700 millimeters drop height, more than twice the 300 millimeter minimum standard. You can see that in this particular impact, there's no penetration of the glass interlayer. In our program at the China Building Materials Academy, and there were 7 of these test programs over a 3-year period, we did staircase impact testing using 2 different impactors. One was the lead shot bag, and you can see the impacts here, which are rated as pass and fail, and here with the twin tire impact. And you can see from both of these charts that 6.38 laminated glass containing Budesite 14.38 interlayer far exceeded the 300 millimeter minimum drop height. This video shows a lead shot bag impact on 6 millimeter toughened glass. In this case, at 450 millimeters drop height. We did a large number of these impacts with 2 different lead shot impactors, and you can see the results on the right-hand side. PVB laminated safety glass, the interlayer PVB, was developed over 80 years ago for car windscreens. It's a flexible interlayer and it absorbs impact while retaining glass fragments from the impact. It thereby protects the driver and passengers from head and eye injuries. Eye injuries was the reason why Japan adopted laminated safety glass in their car windscreens or windshields. But PVB laminated glass is also the most commonly used architectural safety glass in Australia and Europe. In addition to safety, PVB laminated glass provides intrusion resistance, sound reduction, UV screening, and decorative options. It is a multifunctional glazing material. I wrote about this in this 1993 edition of the Glass Australia magazine. I wrote an article on 10 good reasons to use laminated safety glass, which you can see here and which I will be covering in this presentation. PVB laminated glass has been used extensively in curtain walls in Australia, and here are some very long-standing major buildings which use PVB laminated glass for energy efficient and sound control. This was the second, and still is, I believe, no, probably not now, the second highest building in Melbourne. It was in 1991. And this gold tower, built in 1977 in Brisbane, demonstrates that laminated glass containing Budesite PVB has proven durable, and it can be cleaned as easily as ordinary glass without fear of scratching. Burke Place, built in 1991, one of the reasons was noise control as well as solar energy control, and the investment in the glass was paid back in 12 months by the reduced air conditioning costs. I wrote about the State Bank building in my GPD paper in 1997. This is a absolutely fascinating building because it's laminated in annealed glass, like the AMP towers and the previous Melbourne building. And this was accomplished by inspection of the arras glass edges during installation to ensure that in the handling of the glass there had been no damage, and a rigorous thermal breakage risk assessment was conducted on the glass. The Petronas Twin Towers, built beginning in 1993 through to 1996, used 56,000 square meters of laminated glass, and Lawrence Ng of the Caesar Pelli and Associate Company, architects for the building, made this statement to our Laminated Glass News in 2004. Laminated glass has an excellent ability to resist impact load, and it has very desirable post-breakage performance. From 1999 to 2007, the 16,000 windows in the Sears Tower in Chicago were reglazed with energy-efficient laminated glass with Butasite PVB interlayer for energy savings and improved structural integrity. Crossifol safety PVB interlayers are available in different degrees of adhesion levels, and for laminated safety glass made using heat-strengthened or fully tempered glass, such as in the Sears Tower, and for glass that has open edges, we recommend high adhesion PVB, for example, Crossifol Ultra Clear and Crossifol Clear, which was formerly Butasite. Crossifol Ultra Clear PVB has the lowest yellowness index of any PVB, and its long-term stability is demonstrated by the salt spray testing shown on the right of your screen. It's available in widths up to 3,210 millimeters. We did an interview with the director of the architect for the State Bank building, which I showed you previously, Peddle, Thorpe and Walker, back in 2001. At that time, laminated glass constituted more than 1/3 of all laminated architectural glass installed in Australia. And according to the architect, one of the reasons for this is the highly articulated sculptural design of the building, which perfectly defined what they were aiming to achieve with this building. The use of laminated glass gave the architect the flexibility that he desired. But the volume applications for laminated glass, looking back to 2001 and continuing to today, are applications like shop fronts, office petitions, low-level glazing, office buildings, overhead glazing, balustrades, and energy-efficient laminated glass. More recently, over this past 15 years, structural glazing has become more prominent. Examples are balustrades, overhead glazing, floors, stairs, large windows and curtain walls, and the Kuraray structural interlayers to meet these glazing requirements are Century Glass Ionoplast interlayers and Crossifol Extra Stiff, or ES PVB. Century Glass Ionoplast interlayer was launched 22 years ago. It was developed initially to meet the demanding performance codes for hurricane zones in Florida, USA, following Hurricane Andrew in 1992. And we see here the timber missile, which is followed by pressure cycling over several hours. 9,000 cycles, 4,500 positive and 4,500 negative. Now, after over 20 years of proven field performance in impact and structural applications, we can view some wonderful projects that have been done with Century Glass. Note that Century Glass is the only official brand of the Kuraray Century Glass interlayer. And you can see here the history of Century Glass since it was launched in 1998. It is covered by these patents which are issued over the world. It's based on unique ionoplast chemistry. There are no plasticizer involved like in PVB interlayers. The stress strain behavior below the glass transition temperature resembles mainstream engineering polymers. It's up to 100 times stiffer than PVB and 5 times tougher. The use of high-performance polymer interlayers such as Century Glass and Trocifol Extra Stiff has expanded the use of glass as structural glazing elements. Century Glass have provided the enabling material technology. Stiff, tough polymer enables high laminate strength and post-breakage structural capacity. The key to the use of Century Glass interlayer is the associated polymer property information and the advances in modeling and testing methods. These began in the late 1990s, and here's the conclusions from a leading paper that was written in 1999, which showed PVB relaxation characteristics, gave a computational model on statistics of glass breakage and static fatigue, showed experimental stress analyses, and the validation of the model. This is a test setup which was fabricated to test laminated glass at elevated temperatures using the ISO 1288-3 temperature test. This is the effect of temperature from those tests. You can see that the PVB laminate steadily decreases in its ability to carry the load with temperature, while the Century Glass, which is the green curve, which is the green dots at the top, does not begin to drop off until over 50 degrees Celsius. This shows the glass strength comparison for PVB laminated glass, monolithic glass, and ionoplast interlayer, Century Glass. And you can see that the Century Glass laminates develop the least glass stress at a specified load. And also for deflections, the Century Glass laminates develop the least deflection at a specified applied load. This translates into high effective thickness. And in fact, the effective thickness is the total laminate thickness for Century Glass interlayer. And compare that with the treatment of the strength of laminated glass back in the early 1960s from the work that was done for the Sydney Opera House, which gave it a factor versus monolithic glass of only 0.6. The elastic properties of Century Glass and other Trocifol interlayers are shown in the Trocifol brochure that you see here. Century Glass interlayers demonstrate sufficient stiffness or shear modulus over the range of temperatures I showed you and load durations to provide efficient coupling of the glass components of the laminate. This coupling enables laminate weight reduction, increased load resistance, increased panel size, and reductions in glazing supports. Century glass stiffness also imparts significant post-breakage in rigidity and structural capacity. This is a slide on the Trosifol Extra Stiff structural PVB. Its product properties exceed standard PVB in that it has improved post-breakage performance up to 30, but not beyond 30 degrees Celsius. It has very high clarity, and it can be combined with colored Trosifol interlayers. It has good edge stability and is available in rolls up to 3,210 millimeters wide, and it is lower cost than Century glass interlayers. This shows effective thickness of Century glass and Trosifol ES 11.52 laminates over the range of temperatures from 20 to 80 degrees C. And you can see that the Century glass laminate, as I said before, does not begin to drop off in effective thickness the same as that of 10 millimeter monolithic glass until after 50 degrees Celsius, whereas the Trosifol ES drops beginning at 20 degrees. Now let's look at the freestanding balustrade application. And here's a case history from 2005 in the United States. The original balustrades in this baseball stadium had top rails which obstructed the view and drew complaints from the people watching the baseball games. Because of these complaints, after testing, the balustrades were replaced with 13.52 laminated glass containing 1.52 Century glass interlayer. These were approved by the building inspector as required following on-site testing, and it gave baseball fans the unobstructed views they wanted. A comprehensive testing program was done back in 2006 by John Colvin, who was and probably still is the chairman of the ISO Strength Committee. These line loads and concentrated loads used in Britain were applied to the balustrades, and we tested, or at least John Colvin tested, 19 millimeter monolithic glass commonly used for this application in the UK against 21.52 laminated toughened glass with 1.52 PVB and 1.52 Century glass. This shows the panel deflections, and you can see that the green is Century glass and has the least amount of deflection. Similarly, for the glass stress, the Century glass laminate had the lowest stress generated in the glass. Now I want to watch, at least I want you to watch, some impacts on 12 millimeter toughened glass in the freestanding balustrade application. This impact was with a 45 kilogram lead shot bag from a height of 1.52 meters. As you can see, it destructed this balustrade, and the balustrade provided no barrier to fall through of any unfortunate individual that might be represented by that lead shot bag. This is a test on 13.52 laminated glass with 1.52 PVB. And the result here is that the panel remains intact, but collapses, thereby providing no barrier to fall through. This impact is on 13.52 Century Glass with 1.52 Century Glass interlayer, laminated glass with Century Glass interlayer. And you can see here that the Century Glass laminate repels the impact and then comes back and recovers from the impact. And the panel provides a barrier to fall through, which is the performance requirement generally required of glass balustrades. In fact, in the United States, this impact test has been implemented as the requirement by the International Building Code, which the latest revision in 2018, which has the classification of broken and retained glazing after the impact test. I now want to move to testing that was done in the overhead glazing application with point fixed panels. These tests were done at the University of Armed Forces in Munich, Germany, on a typical canopy application over a range of temperatures. They were tested to the German standard DIN 18008 Part 6, which is now a German regulation. And it requires that laminated glass sustain a weight representing a person of 100 kilograms for 30 plus minutes after glass breakage by the twin tire impactor from a height of 900 millimeters. And various glass specimens were tested, including PVB laminated glass with regular PVB interlayer and PVB interlayer with Trussifol extra strong or stiff interlayer and Century Glass interlayer. Here is the result of the PVB laminate at 21 degrees. The laminate collapsed after a very short time with 100 kg load. At 21 degrees, the Century Glass laminate supported 300 kilograms with a deflection of 176 millimeters after 60 minutes time. This chart shows the results of testing at 50 degrees C. And you can see that the that the standard PVB laminate and the stiff PVB laminate could not, in fact, even sustain their own weight at this temperature and collapsed. These are the results for 50 degrees C with Century Glass. The broken 1.52 millimeter Century Glass laminate could sustain a load of 200 kilograms for over 30 minutes. And finally, when a third 100 kilogram was placed on the laminate, it collapsed. Here's a case history going right back to 2002 on an extensive use of Century Glass in the point fixed overhead glazing application. This is the atrium roof in the Endesa headquarters in Madrid, Spain. A panel was removed deliberately after 11 years to check on the condition of the laminated glass, and it showed no degradation in appearance or adhesion. This is the engineer who adopted the use of Century Glass. And Steve Benison, who continues to work for the Kuraray companies, supported Francesc Bellapart by providing him strength modulus and stress strain information. But Bellapart did his own testing as well. And you can see that he's standing here on a mock-up of the laminated glass after both lights of toughened glass had been deliberately broken. Also, the glass construction was shown to withstand 80-degree temperature generated by a deliberately lit fire. Today, we don't have to rely on contacting Kuraray for their structural data. It's all incorporated in the Trossifol Glass Global software tool, which was explained by Vaughan Schoss in a recent Kuraray webinar. Kuraray provides ultra clear interlayers for ultra clear glass. So if you're looking for ultra clear glass, you need to select the right interlayer, either Trossifol ultra clear PBB or Century Glass interlayers, which have the lowest yellowness index in the business and eliminate the disappointing yellow tint commonly found in normal PBB interlayers. This ultra clear clarity is shown when combined with, especially with low iron glass. And this is an example of an ultra clear facade, the Shanghai Tower, which is the tallest building in China. More than 200,000 square meters of Century Glass were used in this double skin laminated annealed glass facade. Why Century Glass? Well, because of this clarity, and also because the wind pressure, the design wind pressure was greater than 7 kPa. The clarity of Century Glass was also used in this project in China, the Shanghai Oriental Arts Center, back in 2003 to 2005. Metal mesh was incorporated between Century Glass layers to regulate light transmission as you go up the building. It also exploited the strength of Century Glass in point fixed support and the durability of Century Glass interlayer. Century Glass has now undergone extensive weathering tests. It has been exposed in Florida for over 20 years. It has undergone EMA, equatorial mounted testing in Arizona, and accelerated xenon testing with temperature and water spray according to ASTM. It has also undergone lab durability tests by boil and bake and by the Coffin high humidity test. It has undergone testing from -40 degrees to 82 degrees. And in the Florida exposure, there have been no defects found after 22 years. I'll move to laminated very briefly to laminated glass fins. These are analysed by the buckling equations given in the Australian Standard 1288 and assume that the glass fin is monolithic. But what if the fin is laminated? Unfortunately, no standard in the world yet has got a solution for this. But Dr. Lubel from Switzerland did research on the subject, And based on Dr. Lubel's research work, Kuraray did buckling testing on laminated glass fins made with different interlayers and proved that the buckling strength of Century Glass laminated fins can be 50% more than that of PVB laminated glass fins. Kuraray provides translucent white Century Glass, which offers the same physical properties as Century Glass interlayers with the added benefits of glare control and greater privacy. Solar heat gain reduction is very important in mitigating the climatic effect. And Century Glass is compatible with 3 silver low E coatings from these 3 suppliers who have done testing with the Century Glass interlayer. Bear in mind that the relative heat gain is a very large number times the shading coefficient, 630 in fact, whereas the U value in relation to solar heat gain is a much lower number. Moving to the subject of security glazing and security threats, Bjorn Sanden gave a very comprehensive webinar on this a few weeks ago, and he highlighted man-made security threats, informing us about the forced entry testing methods and standards that are available. On bomb blast, laminated glass can provide protection ranging from basic protection up to 28 kBA right up to enhanced protection, greater than 276 kPa with Century Glass. And Spall Shield CPET film prevents the spall from the inside of the glass. In the hurricane or cyclone or typhoon resistant glass application, we can see on this slide that building codes have existed in the USA requiring protection against these events for over 25 years. And laminated glass has been shown to resist, as I showed on a previous slide, windborne debris and cyclic pressures, and thereby protects people, properties, and businesses. Buildings exposed to cyclones like Irma that had laminated glass were able to get back to business within days, whereas buildings that were not built to the code were empty while they were repaired for a long period of time. There is no need for window shutters. A 2-year research project that was carried out by the Council on Tall Buildings and Urban Habitat came to the conclusion that Asia-Pacific typhoon-prone regions could take the US standards as a reference in order to upgrade their building envelopes and make them typhoon resistant. On UV control options, again, there was a very good webinar presented a few weeks ago by Alan Gibson, and you can see the UV light transmittant curves for the various options, which range from standard protection against UV to total protection from UV up to 400 nanometers, and allowing all of the UV in the case of Century Glass to come in. There's a Century Glass option for this. Here's a chart on the flooring application, and I can't think of a better example than the Grand Canyon Skywalk. And here's the laminated glass construction, which you can find in Laminated Glass News in 2007. All of the past case histories and stories are on the Trossifol website, available for download. In the case of this application, the upper glass ply is considered sacrificial, and all of the glass plies are broken to determine the ultimate performance limited. In 2019, Kuraray introduced Century Glass Extra interlayer. This provides easier processing for glass laminates, and I gave a seminar on this back on the 3rd of this month, and that's available for you to view on the Trossifol website. It provides less risk of haze formation caused by inadequate cooling rate. It eliminates the need for adhesion promoter for lamination to the air side of glass, and it's less sensitive to moisture, so it provides additional adhesion robustness. And its performance in glazing applications is synonymous with that of the Century Glass 5000 interlayer. And here's one example in a minimally supported application. On acoustics, laminated glass improves the acoustic barrier performance of glazing. Most acoustic interlayers are PVB based, beginning with standard PVB and acoustic PVBs, which can either be the Trossifol monolayer or the Trossifol multilayer, because these contain soft damping PVB polymers. Here is the Trossifol sound control monolayer, and here is the Trossifol sound control multilayer with standard PVB layers and a soft sound damping PVB layer in the middle. Kuraray provides the monolayer interlayer in thicknesses ranging from 0.76 to 1.52, and it's a high adhesion interlayer, so it is very suitable for laminating heat treated glass. Here is a quick sound reduction overview, but to see the comprehensive picture, watch the webinar by Aidan Young on the 16th of December on noise control in buildings with laminated glass. Now, I want you to pay attention to this. Kuraray took up a technical challenge to develop a structural acoustic interlayer. We know that and have seen that Century Glass interlayers give the best structural performance, and acoustic PVB polymers give the best acoustic barrier performance. And we, of course, investigated, could we combine the two polymers? But unfortunately, Century Glass and PVB are not chemically compatible and do not weather well. So we looked at other polymers, and we came up with a multifunctional film with optimized functionality called Century Glass Acoustic, which has structural Century Glass skin layers and a core layer of thermoplastic elastomers, TPE for short. This polymer combination is highly durable, and its acoustic performance can be seen by comparing the sound loss transmission versus frequency curve of the Century Glass acoustics with the monolithic Century Glass interlayer. The TPE core dramatically improves the sound barrier performance. Now, for structural performance, a key question is, how does the TPE core layer affect the glass coupling and associated glass strength? And indeed, the TPE core has reduced modulus compared to the monolithic Century Glass interlayer, and therefore will reduce the structural efficiency compared to a single Century Glass laminator. However, there is a balance of structural and acoustic barrier performance achieved in Century Glass acoustics. The Century Glass acoustic interlayer stiffness, shear modulus behavior has been studied using dynamic mechanical analysis, DMA for short, and 4-point bending tests. And we see that the shear stiffness of the individual polymer components and the tri-layer have been measured at key design temperatures and glass and durations. This is the data on laminate strength and deflection. And we see here that the structural acoustic interlayer outperforms PVB interlayers, and its performance falls between Century Glass and stiff PVB. On acoustics, the Century Glass acoustic gains us a 3 points over Century Glass, and is comparable in performance with the Century Glass multi-layer sound control PVB and monolayer sound control PVB. The Century Glass acoustics can be combined with Century Glass sheeting to provide the large missile impact and cycling performance that's required for the cyclone or hurricane or typhoon application. All of the new stories with Century Glass and other Trossifol interlayers can be found in Laminated Glass News, and I encourage you to subscribe to this newsletter on the Trossifol website that you see below. Here are some question and answers from interviews that have been conducted by the Laminated Glass News, and you can see that there are many of these. Beginning with an interview with James O'Callaghan, the 2018 Century Glass Innovation Award winner for the 1,000-seat theatre, which is part of the new Apple Park campus. This interview was with Bill Marshall, the principal at Studio Marshall, and he asked, why did you opt for Kuraray interlayers, such as Century Glass, for projects such as shown in the lower iron laminated glass application in the slide? Here's a question from the interview with John Koomans, principal at Reed Jones Christopherson, who asked, as a structural engineering and building science firm, how has the development of ever more capable interlayers changed your design capabilities, visions? And he answered that these capabilities allow us to produce better and safer designs, especially in terms of post-breakage. In this interview with Francesc Arbos Bellepart, president of the Bellepart Group, who we highlighted back with the Endesa project, he asked what sort of things, we asked him, what sort of things are now possible that maybe weren't 5 to 10 years ago. And amongst the other comments, he said the most stunning evolution is the glass sizes that are possible, primarily thanks to Century Glass. We asked Michael Ludwig of M. Ludwig Engineering, as an engineering company, how has the development of ever more capable interlayers changed your design capabilities and visions? And he said, the big thing is that Century Glass is so stiff that it bonds layers and lets you think of glass as a plate of steel. And this is a question we put to Joe Kuraray, founder of ALT Limited. What do you think will be the next major breakthrough trend in the world of structural glazing? And he highlighted the fact that building codes around the world are now giving much more scope. And this is a reason why it is becoming so popular in China. And finally, this interview again with Bill Marshall, as a facade design and engineering company, how has the development of ever more capable interlayers changed your design capabilities? And he replied, interlayers like Century Glass from Trocifol have changed the way we can use glass. This opens new design opportunities. So in conclusion, laminated glass is part of the answer to modern concerns about safety and security of people and property and the needs of building occupants for fit-for-purpose glazing, providing safety, structural integrity, comfort, and tranquility. Laminated glass provides many opportunities for enhanced, transparent facade performance. Laminated glass is an enabling technology in providing materials and glazing systems solution. And knowledge of properties in use is essential, along with systems understanding for optimization. And further interlayer research is ongoing at Kuraray. So I'd like to thank you very much for your kind attention and note how Trocifol can support you with consultancy services, laminated glass manufacturing expertise, and the online tools on the Trocifol website. So I'll hand back to Malvinda.
Thank you, Phil. What a fantastic presentation. And Phil, I really envy your perfect timing. With more than 100 slides, you have been able to finish it in less than 1 hour. Wow, what a timing, yeah. I think the attendees had too much information to digest, and I'm sure they must have felt like, drinking water from a fire hydrant, in that case, I can fully understand it was not possible to digest all the information in this limited time period of 1 hour. And we have a provision where the recording of this session will be available on our homepage. So you can go and watch the recording as many times as you want later on. And those who have posted the questions in the chat box, we will be answering those questions one by one through email after some time. because the session was limited and we can't answer all those questions in this limited time. So we will take time to answer those questions through email. We have your email IDs with us, so you don't have to worry. So we will reach out to you. And thank you very much for making this session a success. We had more than 100 people in today's session. And thanks once again for this tremendous support. And have a good day to all of you. Bye-bye. Take care.
Bye-bye. Thank you for listening. Melvinda, the stop button has disappeared.
You can just find it at the same place.
Okay.